Hi, today we're going to talk about the hexbin map for Australia. So here are the libraries: Ozmaps, SF, ggplot2, ggRepel, and patchwork. So using the ozmap_data command, we can extract the boundaries or the geometry for each state of Australia like this. So we have the name of the state and also the geometry associated with each state. This is also called the simple features or SF. So using the ggplot2 command and also the SF library, we can plot our first chart like this. The data is going to come from my country dataset which I've just created, and using the geom_sf we can create the boundaries, and using the geom_sf text we can create the labels for each state. So let's plot it and see what happens. So here is the chart. There's one problem I can see. There's a lot of wasted space on the left side or on the right side of the chart. So how do we fix it? If we knew where our chart actually started and finished, we could have done that. So using this command st_bbox, we can get the bounding box around the chart, which tells us the minimum value and the maximum value in the x direction and the y direction, x min, y min, x max, y max, etc. Using that, we can clip our chart so that it occupies the maximum surface or area in our actual chart. So let's copy the same chart code again. I'm just going to change it to PL2. So now let's add one more command, and the x min and the y min which we got from the bounding box can be used and to try to clip the boundary so that the chart becomes slightly bigger. So using the x limit in the x direction, we'll give the minimum value and the maximum value which we obtained from the bounding box command. So this is the minimum which we got, this is the maximum which we got on the x-axis, and similarly we'll copy it for the y-axis also. There we go. And if we run this command, we would be able to get. So here is our chart, but I can't really appreciate the size, whether it has really clipped it or no. So I'm going to plot it differently so that we can compare it side by side or top and bottom. So PL1 divided by PL2, this is using the patchwork library. So now we can see that it has slightly improved. We can see the Australia map is slightly bigger because it has occupied more space and it has clipped a bit of the left and y dimensions. But I think we can improve it a lot. So now I'm trying to get some values which will really clip the boundaries. So it's just a trial and error, and I've given these values. So I'm increasing the size of the x min and reducing the size of the x max by using these values, and this is just trial and error, whatever works best for you. And now you can really appreciate that the bottom chart is a lot bigger, and it has actually made maximum use of the space available in the chart. So now let's go back to our main topic, which was to create the hexbin map for Australia. We have achieved the first step of creating the map. Now we need to create some random data, and I'm going to create 5,000 different random points on the map of Australia. And to do that, I'm going to use this command, and I'm going to use the pipe symbol. So I should be using the dplyr library also. So I'm calling it now. And now we have 5,000 random points. So once we have got this 5,000 random points, I'm going to create a hexagonal grid which resembles the shape of Australia map. And to do that, I'm going to use this command. So if you look at the actual file which we have now, hexgrid, it actually contains a list of points, which is basically each hexagon. So now we have our random points on the chart. We also have the hexgrid representation of the Australia map. We need to combine it together so that we get the counts for each grid. The idea is that we should actually get the count for each grid, and I'm going to use this command, the st_intersects command, which places each random point within a hex grid. So we'll get a count of that also, and that will give us our heat map. So here we go. We have the geometry for each hexagon, and also the point count. So now we know how many points actually exist within each hexagonal grid. So we have some random values in there, and we can make use of that to create a heat map now. Now let me copy the code from the previous plot and then quickly change it to PL3, and also change the data set to hex_width counts, and I'm going to fill it by the point count. So this is a numeric value. Let's also change the scale fill to a numeric value, which is scale fill gradient n, and I'm using white, yellow, and red color. White color for low values, and red color for high values, and yellow for the mid values. So what happens if I run it as of now? We would have a problem, and the problem is that in the geom_sf_text, we are saying that the labels are coming from the name field, but the name field doesn't exist in our default data set, which is hex_width counts. Now we will have to define that separately in this particular command itself. So data set or data equals my country. So after we add that in, we should be able to run our code now. And here we have a hex grid map of Australia with the names of each state being shown, and also each hex shape is being colored differently. Instead of the text label, we can change it to, instead of this sf_text, I can change it to label and also use repel. So using that, we would actually be able to create much more better labels, which will be more distinguished. I hope you found this information useful and practical. Thank you very much for watching it, and I'll see you in the next one.